Hi, welcome to the Law of Signs. Today we're going to be talking about also the ambiguous case and the area of a triangle. Our objectives are to learn and apply the law of signs so that we can find the missing measures in a triangle, so that we can determine the number of possible triangles for a given set of measures, and so that we can find the area of a triangle. In order to understand this lesson, you're going to have to know how to find the sine of an angle using a calculator, know how to find the angle given its sine using a calculator, and also know how to find both angles that have a given sine value. Up to now, we've used SOHCAHTOA and the Pythagorean theorem to find various parts of right triangles. Today we're going to extend our abilities so that we can solve triangles that do not have right angles. We call these triangles oblique. To solve a triangle, you must be given the measures of one side and any two other parts, sides or angles. We're now going to see how the law of signs can be used to find the missing measures of any triangle. Here we have the law of signs, and you'll notice that it's expressed in two forms. Either first form, where the measure of the side is on the numerator and the measure of the sine of the angle is in the denominator. The other form has the sine of the angle on the top and the measure of the side on the bottom. It really doesn't matter. You can use either form. It's convenient. The thing we want to remember is that angles are denoted with uppercase letters, sides are denoted with lowercase letters, and when an angle is spoken about in its opposite side, they have both the angle and the side have the same letter designation. Okay, so basically the law of signs says that the ratio of the side opposite to the sine of the angle opposite is the same no matter which side and angle pair you choose. Okay, so we're going to use the law of signs now to find the missing sides in this example triangle. We notice first off that we have an anchor pair here, that is to say we have the measure of side B, which is 27.4, and the measure of the angle opposite it, again angle B, and that's 28.7 degrees. So we're going to use this to support our law of signs. First thing we notice is since we have two angles here, we know right away that the third angle, right, we get that by subtracting from 180. So now we know that angle A has to be 49 degrees. So we'll put that right in there. Now that we know that, we can go ahead and use the law of signs to find the measure of side A. Okay, so we're going to go ahead and set up the law of signs. Okay, we'll have side A on the numerator over the sine of angle A, and that's equal to the little b, measure of little b, over the sine of angle B. Okay, so we can multiply both sides here by the sine of 49, and that will give us an equation in terms of side A. We can put this value into our calculator, and that's going to give us, remember to have your calculator set to degree mode, okay, a value for little a of 43.6. So we can put that right over here in our diagram. Now we're going to do the same or similar thing to find the measure of little c. So again, we'll use the law of signs, and we can have, again, side B as our base or anchor pair. So we're going to have little c, side C, over the sine of angle C. And again, we're going to multiply both sides by the sine of angle C, which is the sine of 102.3. That gives us an equation in terms of little c. We can put this into our calculator, and we get out a value for side C of 55.8. And it would be good if you verified all these calculations with your own calculator. And there we have it. We have the missing sides, and we also threw in the missing angle at no extra charge. Okay, now we also want to look at the ambiguous case. And when we're given the measure of two sides and one angle, there are three possible results. We can have no triangle possible, we can have one triangle possible, or we can have two triangles possible. To find out which, in this situation, it's best to use the law of signs. So here we're asked to determine the number of possible triangles given the measure of side A is 15, side B is 25, and angle A is 85. So here we have our anchor pair. So we can go ahead and set up the law of sines. We want to find the measure of angle B, so we'll start with the sine of B over 25 is equal to the sine of A over the side A. And we're going to multiply both sides by 25, and that's going to get us to turn that equation into an equation where we have sine of B all by itself. We can put this value into our calculator, and we find that we get the sine of angle B, turns out is, according to this, 1.66. And the trouble is, we know that no angle can have a sine greater than 1, and that for that reason, no triangle is possible. Okay, now let's look at the next case, where we have one triangle possible. All right, so we're going to verify that now. We're going to determine the number of possible triangles, given that side A is 22, side B is 12, and the measure of angle A is 42. So we've labeled a little diagram here. We have side A and angle A. We're going to use that as our base pair. We also have the measure of side B, so we're going to find angle B first. So we use the law of sines to generate this equation. And then we're going to multiply both sides by 12. That's going to isolate the sine of B and give us a value of 0.3650. Now we know how to find the angle appropriate to a particular sine value, and we have two of them, 21.4 or 158.6. So we want to see now, will both of these give us a possible triangle? Okay, so let's make a little chart. Angle A, angle B, angle C. We know that angle A has to be 42. That's been given to us. We can't change that. We've calculated that angle B could either be 21.4 or 158.6. To find angle C, we subtract both of these values together from 180. Here we have 116.6, so that's legitimate. We have one triangle. In this case, however, this is an impossible situation because if we add up these two angles, we see right away we get a value greater than 180. Okay, so we know that only one triangle is possible. Okay, moving on to the next case. We're asked to find the number of triangles possible given side A of 12, angle A of 20.5, and side B of 31. So again, we're going to start with the law of sines. We're going to go after angle B first. So we have the law of sines with the sine of angle B over 31 is equal to the sine of A over the value of little a. So we're going to multiply both sides here by 31. That's going to give us an expression for just the sine of B. So here we have that, and we can now get our calculator to help us out. And we see that the sine of B is 0.9047, and there are two angles possible here, 64.8 and 115.2. So again, we're going to go ahead and make up a table and see what that gives us. So angle A, angle B, angle C. Again, angle A is 20.5. We cannot change that. Angle B, we get two values. Okay. Now if we add these up and subtract from 180, we get angle C of 94.7, so that's all okay. If we add these up and subtract from 180, we get 44.3, and again, that's okay. So here we have two triangles. Here's one of them, and here's the other one. So we got that using the law of sines. The last thing we're going to look at today is the area of a triangle. And the area of a triangle is 1/2 the product of the lengths of two sides times the sine of the included angle. So don't worry too much about the particular letters. It's the relationship. We have an angle, and then we have the two sides that bound the angle. So the formula is 1/2 the product of the sides times the sine of the included angle. So we have to find the area of a triangular lot. Okay, so we're given a diagram. We see here that we have the included angle and two sides. So we're just going to fill those values into our formula. And then we're going to get our calculator to help us. And there's the area. Okay, so 1/2 the product of the sides times the sine of the angle gives us the area of the triangle. Well, I hope you've learned something about the law of sines, and hopefully we'll see you next time. Okay, bye now.